Hi there. Let's look at solving rational equations. Now, rational equations, well, the word rational comes from the word ratio, and so rational equations will always look like ratios or have fractions in them is the gist of it. And so a rational equation will look like this, where you have fractions in here, and the denominator is going to have a variable in it somewhere. If it didn't have a variable, it probably wouldn't be considered a rational equation. Now, they can be somewhat simple, and they can work their way into being very complex. Let's look at this one. What's nice about this particular rational equation is that it's just a single fraction equals another single fraction. And so you may remember this is called a proportion, when you have a fraction equal to another fraction. That's a proportion, and there's probably the quickest way to solve that is by using what we call the cross products. The cross products means that you are going to, well, product means multiply, so you're going to multiply across at a diagonal. And so 6 times 4 is going to equal, and then you do your cross products the other way, x minus 3 times 1. So what happens by multiplying the cross products there is you get rid of all the fractions right off the bat, and that makes life a little bit easier. So then what I'm going to have, 6 times 4 is just 24, equals, now sometimes this is a different number other than 1, and you would have to distribute it through. Distributing a 1 doesn't really do much for me, so it's just going to end up x minus 3. And then I add 3, and I get 27 for my x value. All right, as we work with rational expressions, there's one other thing that we have to look at. Because our variable is always going to end up in the denominator, like you can see here, we have to also remember that in fractions, we can't ever have 0 in our denominator. You can't divide by 0, that's considered undefined. And so we have to think, well, 6 divided by 0 would be undefined. So what right here is going to make that denominator end up being 0? Because I can plug things in for x. For instance, I could take 27 and plug it in for x. That would be 27 minus 3. So that would be a denominator of 24, and that's fine. But what if I got something else down here for x that when I plugged it in, it created a 0 there? So then you have to think in your head, what is going to make that be 0? And you can do it in your head sometimes as easy as anything. If you can't, then you come over here and you write it out. Well, x minus 3 can't be 0. So if you add 3 to both sides, so basically x cannot be 3. If I got x to be 3 and I plugged it in, I'd have 3 minus 3 and I'd have a 0 in the denominator. So sometimes the software is going to ask you for the restrictions. That's what they're talking about here. This would be the restriction. X cannot be 3. And if I had down here happened to get 3 for an answer, I could not include that as my list of answers because it doesn't work back in the original problem. So I'm going to, in the future, from now on all of these, I'm going to check for restrictions first. And then I'll go solve the problem and check back at the end and make sure that I don't break the rule on my restrictions. Okay, let's keep going. Now, sometimes with these proportions, well, not sometimes, a lot of the times, problems can be set up using proportions, and so it's kind of a quick, nice way to show relationships. So on this one, it says that on a map, each inch represents 2.75 miles. So 1 inch is the same as 2.75 miles. That's the ratio that we have from our map. Now that ratio is always going to stay consistent, so I set it up as a proportion when it asks me what is the distance represented by 5 inches. So since inches are on top, and that's the map over the real distance, I have to decide where to put this 5 inches. And since that is a map distance, I'm going to write it on top so that it matches up. And my unknown is down here, the real life distance. So when I do my cross products, and I multiply this way, 1 times x is x. and then I do my cross products the other way. And let me grab my calculator. I don't have that out yet. All right, so then I'm going to have, 5 times 2.75 when I multiply those. And so I get x to be 1375. Now that is the distance in real life, so that should be measured in miles. Now again, remember we do have this rational equation, and here's an x in the denominator. I promised I was going to find the restrictions first. I didn't, sorry. So on this one, my restrictions, I can't let the denominator be 0. So basically my restriction would have to be x cannot be 0, which it isn't, so I'm good to go. I'm happy with that answer there. They have a lot of word problems here that you use these proportions to set them up with. Okay, so here we have, at the new light bulb plant, 8 out of 100 light bulbs produced are defective. Well, that's your first ratio. 8 are defective out of 100 total that I have. So that's my ratio. Let's set up a proportion. If the daily production is 3,000 light bulbs, how many are defective? So I'm looking for the defective out of a total of 3,000. So line it up. The looking for defective out of a total of 3,000. And I'm lining that up with the same variable. These are defective, these are total. Now this time I don't have a variable in the denominator, so there's not going to be any problem with restrictions on this one. Let's just do our cross products. You multiply it across this way, and it equals this multiplied. So I have 8 times 3,000 equals 100 times x. Well, 8 times 3,000 is 24,000. And divide by 100. So I end up with 240 for my x value. So if I have 3,000 light bulbs, I'm going to end up with 240 of them that are going to be defective. All right, let's try something a little trickier. Those were nice problems because they were just one fraction equals another fraction. Here's a rational equation that's not like that. You have the sum of two fractions equals another fraction, and that doesn't work quite the same way anymore. So what I'm going to do is I'm going to try to get it to be like that, where it is one fraction equals another fraction. So to do that, I have to get this all combined. And typically what we do, because this can get way messier than this particular example, but we look at each one of these denominators and we try to figure out what the common denominator would be. Now, as far as restrictions on this one, notice that every denominator is a number. So since I don't have a variable in the denominator, I'm not going to have any restrictions on this. So if it asks for the restrictions, I would say there are no restrictions. Because I don't have a variable in the denominator. Sometimes it's tempting to say 3 is a restriction or 2 is a restriction. Nope, it's only with the variables that you have to worry about. These are not restrictions. They're never going to turn into a 0 down there. All right, so now let's work on that common denominator. Since they are all just numbers, that makes life a little bit easier. I need a number that 3 and 2 will both go into. So that's going to give me a common denominator of 6. So that means I'm going to rewrite all of these fractions and have a denominator of 6. So that means I have to take this one times 2, but you have to do it in your numerator also. This one times 2, do it in your numerator also. And this one times 3, and do it in your numerator. So what this first fraction will turn into then is and I'm multiplying here, 2 times x over 6. So 2 times x over 6 is going to look like this. For my second fraction, when I multiply, I'm going to have 5 times 2 over 3 times 2. All right, and then the last one, x times 3, which is 3x over 6. Now, I have this common denominator. What works great about having a common denominator is that every single term is being divided by 6 here. So what I can do is I can multiply every single term times 6. If I multiply every single term times 6, well, that 6 times 6 and that divide by 6 is going to cancel out on each term. So if I take everything times 6, all I'm going to be left with are the numerators, and I won't have to worry about fractions anymore, because these will cancel. When I distribute, this will cancel. When I distribute, that one will cancel. So my new equation becomes 2x plus 10 equals 3x. And I don't have any fractions to worry about anymore. And we just go solve. And there's my solution. And remember that we didn't have any restrictions, so I'm comfortable just saying x has to be 10. All right, this one's in a similar problem, only this time you can see, oh, I do have some x's in the denominator. So let's talk about those restrictions. If you look at this, what's going to make that end up being 0? And again, once you get good at this, you can kind of just do that in your head. If you feel like you need to, let me write up here. 3x cannot be 0. So if you divide by If you divide by 3 here, x cannot be 0 divided by 3 is just 0. And then I would do it for the other one as well. 8x cannot be 0, so divide by 8. And 0 divided by 8 is also 0. So basically in the end I'm saying x cannot be 0. That's my restriction right there. So when I get done solving, I'm going to check and make sure I didn't get 0 for one of my answers. All right, so let's go back and solve now. I'm looking at this like I need to get a common denominator with all of these terms. And so it looks like, as far as numbers, I have to find a number that 3, 2, and 8 all will go into. And so I think that number is going to be 24. But these also have an x attached to them. And so I also have to multiply everything and make sure that I have an x in the denominator for part of my common denominator. So it looks to me like I need to get everything to say 24x, and then I would have my common denominator. Look at this first fraction. I need this denominator to be 24x, so it looks like I need to take the 3 times 8, and that would turn into a 24x. So do that there. On this next term, I need this 2 to turn into a 24x. So I'm going to take it times a 12x. But you got to do it on the top and the bottom when you do that. All right, on this last term, I want this to be 24x. So I'm going to just take it times 3. All right, so then what we end up with is 8 times 8 over 24x minus 7 times 12x is going to be 84x over 24x. Equals 3 over 24x. And since I have the common denominator now, I can take every single term times 24x, and then when it gets distributed, every one of those divide by 24x's will cancel. And so usually I just do a big swoop through and cross all that off and say, all right, so then what I end up with is 64 minus 84x equals 3. All right, and this is pretty ugly here. So I end up with x equaling. And typically what they want is you to reduce that as much as you can. I don't think there's anything that will go into 61 and 84, but I do know that a negative divided by a negative is going to end up positive. So my final answer is just 61 over 84. So sometimes you're going to get some kind of ugly numbers. Now notice that that checks with my x can't be 0. Nope, I don't got 0, so that's going to be good for a final answer. All right, so let's try a harder one here. These start having binomials or maybe even a trinomial here in your denominator. So when they start throwing plus and minus down in there, you have to be really careful because this is not being multiplied. And when I try to go find my common denominator, remember that I'm multiplying by something on the top and the bottom. Well, this 3, since it's not being multiplied by the x, I can't come over here and just say times 3 kind of thing. So anytime you have a sum or a difference, you have to look at this like a group, like this is its own thing. We're going to factor this trinomial. Usually they're not too mean with their trinomials. It's just going to be an x and an x, and then you want factors of 6. It's going to have to be a positive 6, so I'm going to want my signs the same. They're both going to have to be pluses, and I want them to add up to that 5. So I think I'm going to go with a 2 and a 3. And look how nice that is because that matches over here, and that's a good sign when it matches. That just makes life easy. Not that it has to be that way. It just makes life easy. Now remember, when you're looking for your common denominator, you're looking to multiply things together to get you that common denominator. And right here, we are now multiplying between these two quantities. So they can kind of be separated. So when I look at what can I multiply together to get me a common denominator throughout, I look at this big messy one and say, all right, so for my common denominator, I'm going to have this quantity x plus 3 times a quantity x plus 2. So that's what this one needs. If I come over here, this one says, okay, you got to have at least an x plus 2. Well, this covers it. So what this one is missing is this x plus 3. So I'm going to take this second fraction times an x plus 3, but keep it in parentheses. And you do it on the bottom also. And now let's look at this first fraction here. It has an x plus 3. What else does it maybe need? Well, if you look over here, we had the x plus 3 covered. What it's missing is an x plus 2. So I'm going to take this first fraction times an x plus 2. Now, once I have that common denominator, or at least once I get this factored, that's a good time to look at your restrictions. You don't really want to look at the restrictions until this is totally factored into some nice binomials there. So I'm going to come back over here and do my restrictions now that everything is factored nicely. Okay, so that's, sorry, my pen doesn't look very pretty there. So I have to look at what's going to make the denominator 0. And it's nice when you just have like an x sitting there, but now you have this x plus 2 that you would not want to end up equaling 0. So that means x cannot be negative 2. So there's one of our restrictions. But we also have this x plus 3 that can't be 0. And so x cannot be negative 3. So those are the two restrictions that we have that we do not want our solution to end up being. Otherwise, we'll have to cancel out that solution. All right, so let's go do some solving. I've already multiplied everything by that common denominator, or to figure out the common denominator. So on this first term, I'm going to go ahead and write this all out. It's pretty lengthy here. I'm going to have an x times an x plus 2. And it's going to be over that common denominator that we have, x plus 2, x plus 3. Equals. On my next one, I have a 2 and an x plus 3. On the denominator, I'm going to have that x plus 2, x plus 3 that I wanted. And now here we have to be careful, because you see this minus sign here? This minus sign means that I'm subtracting everything after that. So I have to be careful that if I start multiplying this by something, that minus gets distributed to everything. So I'm kind of a big fan of changing that minus sign to a plus, a negative, and I stick it up there so that if I have to do some distributing or something with this, that negative will go with it as I distribute. Now in this particular example, I really don't have to do that because, look, I already have the common denominator. I don't have to do anything to my numerator. But it's going to happen, and you have to watch out for that. So I'm going to go ahead and write then a plus, and I'm going to put my negative x up there. Okay, so now look at that big mess. What I'm going to do is I'm going to take everything times my common denominator, the x plus 3, x plus 2, and then it's going to cancel with all of those denominators, and I just have my numerators. Now while I'm at it here, I'm going to go ahead and distribute and get rid of parentheses as I rewrite this bottom part. So when I distribute the x, I'm going to have x squared plus 2x equals, distribute the 2, 2x plus 6, and then I have a plus a negative x, which is going to end up being a minus x. Now this one's a little bit different than previous ones because I have this x squared term, and when you have an x squared term, you're going to end up having to factor. If you want to factor, you want this x squared term, you want everything on one side and you want it to equal 0. So I'm going to bring this stuff over. So I could do this kind of different ways on how I could solve this. I'm going to subtract 2x and I'm going to bring it over here. I'm going to subtract 6 and I'm going to bring it over here, and I'm going to add x and I'm going to bring it over here. I'm kind of trying to do this all in one shot, so all of that's going to cancel and it's going to end up equaling 0. On the left side I'm going to have an x squared, and then let's look at what we end up with. This 2x and negative 2x are going to cancel, but I still have a plus x and I still have a minus 6. So this is going to be a plus x and a minus 6 when I get everything on one side. And now I'm going to factor. So x and x, factors of 6, but this time my signs are going to have to be different so that I get a negative 6. So I'm going to have one of them a plus and one of them a minus. And I want to end up with a 1x for a middle term, so I'm going to get a plus 3 and a minus 2. So now, let's keep going. Remember this from your previous chapter. You're going to set each of those answers equal to 0 and see what you get. So I have x equals negative 3 and x equals 2. And there's my solution. Except, don't forget about those restrictions. This says x can't be negative 2 and x can't be negative 3. And this one's okay, but looky right there. That can't happen. I can't plug negative 3 back into the original problem. So what I do is I X that out. That is not going to work in my solution, and this is the only solution I have. All right, that's a doozy. Those are long ones when they look like that, but you'll get better at it as you do them, and they're not so bad. I have one more for you to try. All right, this is going to be similar to the last one that we did. What's weird about this one is that you got this 1 sitting right here. And so we have all these fractions, and then you got this 1. Well, you just turn that into a fraction. So I'm going to rewrite this, and it's going to look like 1 over x plus 1 equals, and I'm just going to write it 1 over 1, minus 5 over x plus 9. Let's come look at our restrictions. Anything that makes your denominator 0, which in this case looks like it's going to be, and you go through each one of your denominators. I don't want x to be a negative 1. That would create a 0. And then it looks like this one doesn't have a variable in the denominator, so it's fine. It's not going to be a problem. But this one does, so I wouldn't want x to be a negative 9, because then that would turn that into 0. So x cannot be negative 1, comma, negative 9. That's kind of a shortcut way of writing what your restrictions are. All right, so let's go find our common denominator. Looks like, remember when we have this plus or minus going, you have to look at that as a group of things. So I've got to have an x plus 1. This one is just a 1. This one I've got to have an x plus 9. Oh, and look at that minus sign. I don't like that, so I'm going to do plus a negative on it. All right, so common denominator, looks like I'm going to have an x plus 1, and I'm going to have an x plus 9. Didn't mean to swipe through that, sorry. X plus 1 and an x plus 9. And the 1, if it was a different number, like a 3 or a 7 or something, I'd have to have that too. But a 1 isn't really going to change anything. So I'm going to rewrite all of these. Looks like on this first one, I need to have an x plus 9. And on the last one, I need an x plus 1. But what's tricky is this 1 that I had in here, I don't have any of those denominators, so I'm going to have both. I'm going to have the x plus 9, and I'm going to have the x plus 1, both of those multiplied. Kind of squeezing that in there. All right, now let's rewrite this. So I'm going to take my 1 and distribute it, so that's no big deal. That's going to become x plus 9 over that common denominator equals, this one not as nice, I've got to have both. I've got to have the x plus 9, I've got to have the x plus 1. That's going to be over the common denominator. And then plus, and now here's what I was talking about earlier. This negative needs to get distributed through those parentheses. That's why I changed that to plus and negative. So let's distribute a negative 5. So it's going to be a negative 5x and then a minus 5 over the common denominator. Then you take everything times the common denominator, so it will cancel out on every term. And all of those go away. And I just have x plus 9 equals. Okay, I didn't do it last time because it was pretty messy, but I'm going to go ahead and do it here. You need to FOIL through this and get rid of parentheses. So the first gets me x squared, outer gets me 1x, inner gets me 9x, and last gets me 9. And then I'm going to have plus a negative 5x, or really I prefer just to change that to a minus sign at this stage. It's going to be a minus. And then same thing here, this is going to end up at minus 5. Now as I look at this, I only have one x squared term in that whole mess, and it's right here. And so just like last time, if you have an x squared term, you're going to end up factoring, so you want this to equal 0. I'm going to bring everything to this x squared, so I'm going to subtract the x over here. Oh look, that's going to cancel nicely with that. And I'm going to subtract the 9, so I'm going to bring it over here. I got a mess of stuff going, don't I? But if I can get both of those to cancel out, then I'm going to have a 0 here. Equals. Okay, I have a whole bunch of stuff on this side that we need to combine. And so let's start with the x squared. This is the only x squared. So I'm going to have that. I'm going to cross things out as I go because otherwise I lose track sometimes. So I've got that one covered. Now let's look at the x's. I've got this 1x and I've got a minus 1x, which handily is going to actually just cancel out, so I don't have to worry about that. But then I have a 9x and I have a negative 5x. So a 9x and a negative 5x is going to get me a plus 4x. So then those are going to be gone. Okay, so then that's gone, and that's gone, and that's gone. What do I have left? Oh, I have this 9 and this minus 9. Well, that's going to cancel beautifully, and all I have left is a minus 5. So all of that mess really simplifies pretty nicely here to this quadratic. All right, so let's see what I can do here for... All right, I'm going to come back up here to the top, and I'm going to factor this. So it's 0 equals, and I'm going to come up with my factors. And it's going to be x and x. Factors of 5 have to be 5 and 1. Since it's a negative 5, I want one of them positive and one of them negative. And since the 4 that I'm shooting for is positive, I probably am going to want a plus 5x and a minus 1x. Now you set each of those equal to 0. So x is going to equal 1. And I check that in my restrictions, and it can't be negative 1, but a positive 1's okay, so I'm good there. And then let's check the other one. So I've got an x plus 5 equals 0. So then x is going to equal a negative 5, and that works with my restrictions. So this one has two solutions, x equals negative 5 and x equals 1. And both of those will work in the problem, so I don't have to cross either one out. All right, there you have it. Good times, huh? Good luck.